Good afternoon, even though it feels like good morning for me. It's my great pleasure to host this special session on the way large language models, and you better learn the acronym now if you don't know, it's LLMs, and how these can contribute to unlocking new frontiers in humanities and social sciences. Just a quick question. How many of you have been playing with ChatGPT once it's been launched and revolutionized the way we summarize information, the way we write, the way we ask questions, and so on? Show of hands.
You're in the right room then.
Well, that's not exactly what we'll talk about today. So, sorry, Maggie, we're gonna have a massive, but I just thought I'd let you know to start with that this is not what we're going to talk about. Here's the bell. We were early. So at the moment, we're not quite sure what the value of these LLMs are for social science and humanities and innovation studies in general. So how do we use these things in research? So this panel, we have three great speakers from very diversified origins, so both in terms of backgrounds and the type of institutions they work in. So I will not, give you very long bios. You can Google them, LinkedIn them, then, you'll find much more information. So let me first present Arash Ajikani, or Ajikhani, to pronounce it more properly. He's a research team leader at VTT. I'm sorry, I will not pronounce that. So take it as VTT, Technical Research Center in Finland. We also have online with us Roman Jurovetsky, and I'm sorry if I massacre your name as well. He's associate professor at Aalborg University Business School in Denmark, and couldn't be with us today because there was the ferries wouldn't work in time. And finally, Pietro Cucciata was a PhD candidate under my direction at Polytechnique Montréal. So quite a varied a group we have. And since we were in this room this morning and there was a complaint that there wasn't any women, I mean, I'm chairing this session and I'm very much a woman. So there we go. So to start with, we'll start with Roman online. You've been involved in this innovative field for some time. You're at the forefront of these models, and so I presume that your research has evolved to utilize these models, which are increasingly complex. So basically, tell us more about the history, the evolution of the development of these AI-driven tools, just to call them in a general way, and how they've been used in research. And with the hype and fear that we have in the media every day about how it's going to impact our society, we have the impression that these LLMs are quite a different beast from AI beforehand. Since the advent of ChatGPT, then people have started to realize. So, Roman, you have about 8-9 minutes. You're already sharing your screen.
All right. I hope everyone can hear me. Catherine, thank you very much for inviting me for this session. And yeah, I'm very sorry I couldn't be there. It's a bit embarrassing because it's actually really around the corner, but there were other commitments, so I couldn't just make it in time to be in Gothenburg and then be back. So yeah, a little bit messy, but I hope it's okay to be online here. And yes, so I've been involved in, I've been using these things for research purposes now pretty much since they were out there. And I've been also involved in the Danish community that actually creates the Danish language models, because Denmark is quite an underrepresented language actually, or in country, in the development of this. I've been also, more on the technical side involved in my spare time, actually creating some of these open source models that are actually able to handle Danish. And what I wanted to talk about today is, again, not how to use ChatGPT. That's been already said in your manuscript. So this is not this kind of talk, and this is not what we mean in the session, I think, when we talk about using them in research purposes. But what I want to talk about today is actually how do we use large language models as a thinking engine and not as a search engine. And this is a very important distinction that's already been mentioned before. These things, despite what you can use them for, are not necessarily good search engines. They are thinking engines. And I will give you a couple of examples to showcase what this means when used in a research context. So when I use them, I think of them as a research assistant. And of course, a research assistant that's not only, I mean, in this kind of chat interface type of thing, but in a setting where you actually write code and automate something. So I think about them as my army of research assistants that can go out and analyze 20,000 patent documents for me. So that's the kind of way how I think about this technology. So a quick overview of things that I will cover here is first this whole generalist nature. Why this time? I mean, why is it different from the AI that we've been have so far? And a couple of points that are relevant in this context: the generalist nature of these models, and this kind of ease in which we can alter their behavior, the high flexibility regarding the inputs and outputs that they create, again, as compared to models that we had before and AI systems that were built before. The changed division of labor regarding the development. So there is a very new and interesting cost structure that has emerged and that allows us to do different things than before. The ability to clean data and create synthetic data for various applications. And then maybe if we have time, and I guess we will also discuss it later, the whole idea, notion of hallucinations and crazy behaviors that can emerge and that we need to guard against. Let's start with the generalist ease and the ease of, generalist models, ease of altering behavior. These models are as any other models. They have an input and they have an output. And in the middle, there are rules. In former times, when we created models, we had to specify rules. You know, if you ran some kind of agent-based modeling type of research, then you needed to specify, all the equations which then guide the behavior of these agents. Then we had machine learning for a while, where we trained models to do very specific things, and where we try to optimize accuracy or recall or any kind of measurements by providing them with very specialized data, with specialized inputs and outputs. They learned patterns from that, and then we could use it for new data. But now we have this whole story with giving them instructions or instruction and a few examples, and they actually start adhering to the rules. So we are able to describe the rules by which they somehow go from an input to an output. That's like an interesting thing here. And an example that I've been working with, for example, last year was a collaboration with the UNESCO, where we basically said the input are keywords extracted from patent documents, identified certain clusters. The output should be an expert assessment of what this cluster is actually about. And that allowed us actually to automate the analysis to quite an extent, where we could draw on GPT-4 back then to interpret certain clusters of technologies and then show these interpretations to the experts that we had access to, which allowed us actually to speed up this whole process and actually generate really, really good results. So far, no one complained at all. So that was, for example, one application here. Again, we said, you're an expert, patent expert in a certain field. Analyze these inputs, tell us actually what the application is about, and that how we use it there for hundreds of clusters identified over many, many documents. Another application here is function calling. So this is something that these models are built for more and more. It's the whole idea of telling the model precisely how you want to structure the output. So saying you output only this JSON format, and by doing so, and actually more and more models are really getting really good at this, we can just automate things and let the model repeat things thousands of times in a certain way. So here's an example how we use it with another colleague to, for example, extract data from thousands of unstructured interviews recorded back in the 80s and 90s and actually create data sets that we were not able to create before. Another example is now coming up with the same with imagery, right? So again, structuring things and cleaning data, the kind of work that we actually needed people to do before to be able to do research. So I think that's quite exciting. And again, here it is these kind of applications where you can say, okay, how do we guarantee consistency? How do we guarantee quality? And there is more and more ways emerging to do so. So that's quite cool. I mentioned this quick thing about the cost structure, and we are in an interesting situation where we actually have these large companies that invest millions in the development of these models, and we can actually use them now. So, and I think it would be actually stupid not to, because it used to be the other way around, that we would be developing something and then these companies would, capitalize on that. But now we are in a slightly different situation, even though there is more to that than what I can mention today. I mentioned before data preparation and distillation. A big chunk of work in old times, or still, went for data cleaning, data preparation for all kinds of quantitative use. And we can actually use these models to prepare data and to clean up. And here's another example. So here I have a prompt and a setting where I tell the model to look at patent documents and then create evaluations. So here it basically, what it has to do is to kind of, identify what is the application, is it direct use on a person or not? Is it, what is the risk evaluation, risk level of the certain technology? So I can use it here also as a kind of an expert, but not really in this particular setting. But it basically does a task that I would otherwise use a research assistant for after a lot of long time instructions. So, and here, this is the result, right? So here's a patent, and then this model that we actually fine tune, then we take a small model, we fine tune it, and now it's actually cheap enough, it's open source, and we can actually control the quality of that after evaluating it. And I can apply it to, again, thousands of documents, relatively cost effective. I'm pretty much out of my time, so I will stop now here. And yeah, thanks so much for listening.
So our second presentation, let me introduce Pietro. So the question I asked them is, although LLMs have been recently introduced, there appears to be, a few works that have been presented so far, but there's, more leveraging their capabilities. So you did an overview for, part of your thesis of the pertinent literature about some of the use cases and applications of LLMs in the field of innovation. So take us through this.
So I have one. Thank you, Roman. This was a great introduction of the LLM. So my presentation started with a step back, just to understand what has been done until now using NLP in the innovation study. And it started with two affirmations. First is from Chen et al. In 2022. They says the NLP and the methodology is contaminating a bit all the field, all the other field, and there is a growing trend on the use of this methodology in other field. And then there is a paper that has just been published this year. There's the paper there is natural language processing on the front end of innovation. And it's in this paper, there's a confirmation that there is a growing trend. Although this paper is in a niche study, it's at the front end of the technology exploration. There is a growing trend, as you can see in the last 2021 and 2022, on the use of this NLP methodologies in our field. And for what they are using, there are several categories. So they are using for especially for topic modeling. I saw already some presentation today. They use this to make emerge some latent topic regarding, for example, the patent. But there are like all other use cases that can be where this NLP methods are being applied. And so what happened with LLM is that we can use, all these methods are still valid, but there are enhanced. So there is other application, other use case that we can do, as Roman mentioned just before. And this is, I think, one good paper that I found, also published this year from Palace et al. And in this paper, I choose this paper because it's interesting for two main reasons. One, because this paper was first built, as the author explained in their methodology, was built because was built. It's a study on the public value of the patent. And before they built the guidelines and the definition for the research assistant to use it. But then when GPT-4 was out, they thought that this could be like a really interesting experiment to use ChatGPT-4. So what they did is they substitute the researcher with the GPT, and they follow the guideline that they elaborate for the researcher itself. And then so they saw that there were like really interesting results because they tried to follow each step with the evaluation. So they evaluated the result of ChatGPT with some statistical metrics, and then they also tried to took a subsample, and they let this subsample be evaluated and verified by a human. And finally, they passed for a prediction. And also this prediction was evaluated through statistical metrics. So the important thing is that what LLM and especially in this case, the generative LLM allow us to do is now to kind of be a research assistant for us. And I mentioned that there were like the three types of evaluation because on the literature review for the NLP method, one problem that is found by Just is that most of the time a researcher use this method, but sometimes there is missing the evaluation, the validation point that is really important in this use case. And I think the Araj can build on that.
You've talked to us about what's in the literature, but this weekend you had your first paper published, and it's just right in time. It's well arranged. So maybe you can talk to us about roughly what this paper is about, and then we'll go to Arash.
Yes, with pleasure. So the paper is called First Impression of Sustainable Innovation Matter, using NLP to replicate the BLAB environmental index by analyzing the company on page. It's published in Technology Forecasting Social Change, so if you would like to read it, it's really interesting. And I will show you briefly and concisely what is the pipeline and the conclusion. The main idea is that we saw that there is this company, there's the B Corp company, and which goal is to evaluate it's a non-profit organization that evaluates the company on the sustainability score. And the score that they provide are mainly regarding, so there is a unique score that is created by mainly 5 areas. There are the evaluation workers, environment, governance, community, and customer. So we focus on the environment, and the main idea was we saw that there was the BLAB environmental score, and we tried to see if actually the communication, so the company website was plus a framework of the zero-shot text classification could be used to replicate the BLAB environmental score. So this is a bit the pipeline of the paper. So we start with the data. So we went to scrape the company homepage, and then we combine this data with the score from BLAB. So with the data from BLAB. And we use this on the framework of the zero-shot text classification. And since the zero-shot is just a framework, we use the NLP model BART, so the large language model BART. So how works the zero-shot text classification is that we give we insert to the framework the sentence to classify. And because we don't have labels, so we give the model to the label, some label, and then the model, based on the knowledge that it has, is select what is the appropriate label, giving a score from 0 to 1. So it's a probability score based on which appropriate label to classify. So in our case, what we did is to dividing the website in paragraph, and then we select the candidate labels, the same one the BLAB used to create the environmental score. So in this case, we obtained this web-based that we call web-based environmental indices. And what we did is we sample a part of this score. We first evaluate the result was no random, but there was was a reasoning. It was interesting. And also there we saw that there was a correlation between the indices that we created with the score. So then the last step of the paper was to do a regression. So then we create this base model of regression. We add others, but for the purpose for the briefly, I just gonna present the main one, in which our dependent variable is the BLAB environmental index. Then we insert some control variable because we saw that there were like some other indices that were affecting our BLAB environmental index. And we also, interesting one, since there is a random time in which the company can be certified, we insert as the year as a control variable also. So then we also add the web-based environmental indices. I'm not gonna go in detail how do we create it, but we saw that there were, since we had multiple of these indices, we needed to reduce the dimensionality. So we did the principal component analysis. And finally, we get this two main regression that I will present in this case. And I think the most interesting part is the six indices that are on that we created. They're all mostly significant. And also the R square represent the variance that we are able to represent with our regression. So we saw that there were a good result. And also when the second regression is more related when we add the characteristic of the company that we were observing. So characteristic related to the size, to the nation, and also to the sector where the company belongs. So what are the main conclusions are that this web-based indicator are effectively proxy for the real environmental index if we assume that the BLAB environmental index is a real one. And this zero shot, the framework that we used was really interesting because allow us to, I don't know if some of you work with the text data, but there is a lot of cleaning to do before to use it. But with this, we avoid most of them because we let the model interpret the text. And then we contribute a bit also to the signal theory because the main goal was to see how the company are picturing themselves is actually what they're actually doing. So since we had the true value that B Corp, so we were comparing how the company present themselves with what they really do. So I think this was a really interesting result. Thank you.
Oh, yeah, do ask a question while we have
I don't really understand what do you mean when you say we let the model predict the probability of a given, because do you have to train your model on your data or it is already trained on other data and you let the model predict the probability?
Yeah, sorry, because I cannot add the more detail, but actually the model is not trained at all. So you just, for this reason, I let the model because it's like the knowledge that the model has. And this work was done before all the GPT-3 was out. So now for sure, like we could have a more interesting result, I think. But even the interesting part was that it was completely the knowledge of the model. So we were just evaluating what the model already knew. So for this reason, we also like the text was not cleaned. So we save a lot of time on cleaning the text and we let all the model interpret it according to the knowledge.
Could you make sure that the presentation of or what companies wrote on their website was not caused by a company being a B Corp, so that there is communication rules, etc., that prescribe to the companies who are B Corps certain types of communication?
Yeah, so what we did is this is actually now we gather the data. We selected the data 1 year previous, and so in the range of 1 year, because obviously like there are some companies that were certified in 2008. So we went through the Wayback Machine. I don't know if you use it.
All right. Okay. Wonderful. Yeah. Good thinking. Love that.
it's just as well it's been published. So now it's time for Arash. In our conversation when we prepared this panel, you mentioned, a smorgasbord of different applications of LLMs, in industry, and you mentioned, evaluating the carbon footprint of companies. So, take us through, some of these examples so that, we venture a bit out of academia into, maybe what I would call the real world. But I mean, it's a session about AI. So, real world is very much in companies.
Really?
So go ahead.
Thank you very much, Catherine, for the introduction, and happy to be here. We try to be unconventional, so it is not about promoting like use this or don't use it. It's like a very true reflection, and this is a collective of perspective from the projects. I myself, I'm a research team leader, also have an academic role in university. So that gave me opportunity to be in university, kind of observe how these are been kind of coming to popularity and university students are using it, but as well how in the companies and research sectors they are trying to adapt and get some utility out of these models. Earlier we had a reflection on EU AI Act. So this was collected by EIT Digital. We had a round of discussion, and I thought that because it's very recent, I'd probably share it with you because EU AI Act has came into force just 2 weeks ago. There has been a lot of criticism, and there might be go for another round of revision, but then that implies that these are very much new debates and new angle points to our technology and society, and it's always good to have an open debate. A couple of the points that I collected, and this is a kind of a VTT reflection, not only me, but the other researchers in this area, is that there's always a need for kind of this balancing of regulation and innovation. One kind of challenge in EU is that there is a brain drain in EU regarding AI skills and AI expertise, and oftentimes this regulation stops and creates barriers, and this needs to be considered. The other aspect is to kind of promoting the human agency in all of these models development. We want to be on board when these models are kind of created and they are coming into force and using our different systems in the society. So the human agency is definitely another point. Then about complementarity of AI with what humans are doing. This is also was very much reflected in the Horizon EU and the European Commission landscapes for research. And then, of course, the kind of distribution of the tools and the benefits from these models also was another point, because we know that these models are very expensive. They also create huge gaps because of the ways in which they are used. It also creates additional gap in our societies if they're not used in a ethical and responsible way. Then very quickly, some trends. I mean, you might read a lot about generative AI, but I think there is like maybe this is my aggregation and my reflection on what is going on. So what is happening is that we are now seeing models getting cheaper, getting faster. So this is one trend. Normally, when it's about LLMs, it's about the cost per token. So this is dropping, and it kind of part of it is due to competition. Google's and Amazon's and OpenAI's are competing to try to create the dominance. More capable functionalities are coming with the LLMs. If you have noticed, the context window is just keep increasing. That actually gives much more capability with analyzing more kind of content, regardless of document or video or whatever. One other trend very much driven by, for example, NVIDIA, one of the major players, is the on-premise AI capabilities. And this is basically because now the data suddenly has a huge amount of value, and companies are not very comfortable to just setting it off to some provider commercially to be analyzed. So then this NVIDIA is basically going around the corner and trying to sell their server racks for hosting and training the AI models. The debate on restricted and specialized AI models is something that we have also published very recently, that not for everything you need to create or use LLMs for. I mean, it's also for energy efficiency and also having control, because still we believe, and this is like a consensus, that when certain things get to some level of complexity, it becomes very difficult to diagnose. And for not all the purposes we need to use LLMs, and that's what we are highlighting in that paper, and very much in the direction that it's more about specialized AI models rather than just using baseline AI models for all of the cases. The battle between open and closed models is getting closer, and that's a good thing. Comparatively to last year, now we see that the gap between the quality of open source models are getting better, and this is substantially a good thing happening on the open source communities. And then finally, on the LLMs evaluations, that Now this is the next big debate that now eventually we have machines and tools that just generate content, but efforts now is being transformed to like how to measure and how to validate what is coming out of these models are reliable and grounded into the facts. So the frameworks are just populating in this space that are good to see. One other aspect is that very much alarming is the fact that AI is very much filling up the internet. To some extent, it's creating a certain pollution. We know that how the old search engines were working. They were indexing a lot of previous material, but now this aspect is becoming very diluted because we have created the machinery that's just populating content without much of a human control, and that's very alarming as well. I think you have already seen a lot of these examples also in academic discourse that papers come out without getting rid of those very generic things that GPT says. So this has been already detected in some of the papers and they have already been taken out. But then again, this is the tip of the iceberg. Still there are people who read the paper before submitting, so we don't know about those. But that implicitly doesn't really mean that it is a bad use, but it kind of highlights that the capacity of us as humans is not in the same level of when these models are just populating the discourse. So what consequences that brings? Of course, that you could argue that there is a rapid generation of falsehood. In a way, if some falsified knowledge gets very dominated, that eventually becomes like a fact. And normally, I mean, I have seen it, probably seen it in the other sessions that there's like papers that do text analytics, NLPs, and they are really looking at the aggregates. So imagine like if an aggregate is just being promoted by an LLM, and then suddenly you're just counting those, you're eventually getting a very biased image. And then eventually we have this amplification of lies. So LLMs don't have the capability to discern, the fact from the artificial or nonsense, so they're just proliferating the whole discourse. And it's become a vicious cycle because so far the current LLMs are designed based on the human knowledge that has been documented before. So imagine if that knowledge, which is our kind of artifact as a species, become diluted by nonsense, or one of my colleagues kind of call it like a bot shit. Then what would be the amplification of it for the future models? Because they will become biased. And the way that these models operate, in a way, they are really penalizing the end of the spectrum. I mean, if you think about knowledge, it's like a bell-shaped curve, and then you have the nuances and outliers on the very kind of the tail of this shape. LLMs really exaggerate on the very common understandings, and those kind of left out. And over time, we don't see that representation in the data, and eventually the vicious cycle is already started. And this is a big challenge ahead. And already, I mean, we have seen evidence that papers now been written by GPT. There has been a lot of evidence now. It's been also documented that conferences have detected a lot of material that's been just written by last-minute submissions, long text, and very kind of this delve effect that they have some terminologies that is very popular with GPT. But at the same time, there are also reviewers using that. So that's also became evident that like in one of the instances, there was 17% of peer review done by AI. So in a way, AI is now writing for AI to be evaluated. I mean, this is like, again, a very extreme thing to say, but early signals of that is very evident. So what is really happening, and I try to put it in the context of the science technology debate. There is a lot of information, and this is just the bulk numbers from patents, publication, tech-related articles, and everything. But then this is now on a high rise. By any measures, if you look now, there's exponential growth for all of this content, and analyzing it's become problematic Because, okay, at one point we have, and Pietro and others and in other sessions, there is a very good use cases of using LLMs and NLPs to analyze the content, but the content itself is also expanding, and there is kind of this inflation rate for whatever is coming out. So the challenge of identifying novelty and nuance is becoming much, much more difficult. And then, at VTT, we are trying hard to kind of come up with models, and these are like some of the things that we try to create to analyze and get such signals so that we can also embed human intervention, human kind of expert opinion, in order to kind of create some sense out of these, in a way, madness and kind of inflation about content that we are now observing. In another instance, this is another pipeline. We try to automate, for example, the life cycle sustainability assessment for companies. And this is something been done by humans. Basically, we have been commissioned to work for companies to understand what is their kind of the carbon footprint, or what is their life cycle sustainability assessment of their activities. And this is very much done by individuals going, Googling, searching, trying to collect documents and try to organize them. But eventually we saw that there is a very good gain by AI when we transform these processes to like an LLM to kind of go through these processes. Eventually, again, the core of the effort is very much pattern recognition. The human also does the same. They search, they read something, they kind of look at some guidelines. These are very much something we can also mimic with the LLM, because they are very good in pattern identification, pattern recognition, and just creating this consensus among many multiplicity of the content. We are trying to use it in the defense sector. This is also a new direction for VTT, and also for the European Defense Fund, that they are also recognizing the use of LLMs to kind of create this interoperability between multiplicity of the sources that comes from the intelligence services, and eventually large language models can really have an impact and have a kind of a utility for making things a bit more straightforward. Yeah, this was the paper I already talked about, the kind of the critical use of AI and the specialized AI versus general use of AI. We realized that for very particular tasks, when you use baseline models, they are very liberal. So basically, they always try to kind of satisfy you and kind of make you happy with whatever you're demanding. But then we realized that when we train a model ourselves with a very restricted training data, we have much more control as humans to very much insert that, okay, what we accept as yes and what we don't accept as yes. So these kind of divisions are important, and we put out the debate just to say that, in the very particular case of sustainable development-oriented detection of, kind of science and technology artifacts, when you use GPT, it's very liberal. It basically says that everything is related. But when we have a very critical kind of a training data, we realize that, okay, we can actually have a bit of more selection and control and diagnosis there. Some pipelines, I mean, I try to go over it. I think time is not there for me. But again, the core of the discussion here is to kind of be on board with the development of such pipeline development, because you can also insert a lot of control. And it's not a very favorable thing to always jump on like some tools in order to use it, but knowing a little bit of the baselines and kind of going through building such things is also kind of an organizational learning where one can influence the way in which they can impact. On that note, I think I will finish it. But the last thing I would also wanted to leave with you, I was just walking yesterday in Gothenburg, and I was having a chat with GPT about the Schumpeterian innovation. And it ended up like a very interesting 1-hour discussion. And I thought that, why not to kind of compile it as something, especially, if somebody's not very familiar with such debates. And then I started working with it today morning, most of my morning, and then eventually it's a chatbot that is accessible if somebody wants to use it. I think there is a QR code that eventually walks you through innovation theories, and basically having a chat with a mentor that knows about these things. I try to do the most care to make sure that, you know, that the material that I'm feeding into it is relevant. And I already got some laughs from my colleagues. But, you know, the point is that these are going to come. I mean, maybe not today, we're not going to rely on it much, but just think about 3 years from now and how you're interacting with some AI to learn about some concept. And by that note, thank you very much. And sorry if it was a little bit extended, so I tried to be quiet.
I think you just created some competition for the presidential address that's going to occur just right after this. Well, thank you all three for opening up the world of LLMs. Because of time, I'll just go straight to the question. You had a great chat with ChatGPT this morning. So my question is, are we replacing, social and cognitive proximity with a technological proximity? Because, for example, Roman, you mentioned in your presentation that ChatGPT was not a search engine; it was a thinking engine. So maybe Roman, why don't you start on this? Give us more
It is a
information
thinking
about
engine.
this.
I mean, it is a model that basically receives an input and creates an output. And when we use it, we have the word context and context length came up in some of the other presentation. And in fact, the interesting part about these generative models is that we are able to provide them with an instruction telling them what to do, but we are also able to use this context length to provide them with data. So basically the kind of data that we want it to reflect upon. So it's think about a research assistant that you tell, here is an interview, try to extract information from this interview or evaluate along a certain scale. So, and this, if you do this, then you can be actually quite certain, given the current state of the development of these models, that they will not just invent something, but they will actually reflect and think and process the data that you provided them. The counter situation is that, write me a story about XYZ, and then you just rely on what is in the model, but you cannot be really sure, right? Where the data come from, that the model was trained, all of these things. But what you actually can be quite sure about today, and you can evaluate it and you can fine tune it, there is different pipelines of doing it. You can be quite sure that if you provide it with certain inputs and the data that you wanted to think about, or you provide it with an output template, you provide it with clear instructions about how to think about the data, how to evaluate it, then it actually will follow your instructions and behave as a research assistant would behave, just much cheaper and faster. So that's my take on it. And this is where we can actually be certain and sure to use them in research. And the other story is, of course, I go to Paris and I ask it, hey, what should I see? I have like 40 minutes and I'm here right now. And then, it tells me something. It may be true, it may be wrong, but that there are no stakes in that involved, right? If I just walk a little bit around and don't find the right place or something like this. But in a research setting, I think it's about thinking engines and not search engines.
But Roman, you're at the stage of your career where you have needs of research assistants. PhD students might have a different take because you might want to be doing augmented tasks. So as a PhD student, Pietro, what do LLMs allow you to do that you wouldn't be able to do otherwise?
Yeah, I think especially I feel that in our field that is more interdisciplinary. I think we need someone that can kind of give us indication, not to be like I don't treat it like an expert, because I'm not an expert in certain fields, so I cannot understand if it's an expert or not. But at least an introduction, a gentle introduction, and also a critical introduction. In the sense like you don't only ask, for example, about some methodology, but you ask also why, and you go deeper than this. So just don't resolve the problem. Also, it's like a teacher. It can introduce you to a method, to an argument, and also can give you feedback about I don't know, like critical writing, for example. So if something is not logic when you write, it can give you like this critical writing. And I think for me, another use case that I feel is interesting is especially because I'm collaborating with with, for example, the people that manage our server, our database. Sometimes it's I don't know if you have this interaction, but sometimes it's difficult to explain the problem, right? Because you're missing some words, something. So I think it's a first filter could be like to just have maybe a talk to understand what are the key concepts that before it was taking like hours, and now it's a bit more easier to go and ask what could be the problem and how to explain what's the problem.
So partially replacing what our jobs is as teacher. Okay.
An introduction.
So let's go for a beer. We're redundant. Yeah, go ahead.
I think one thing I've been thinking about how language dependent is. I mean, because if we speak many languages, we know that there are many different grammars. It's quite difficult to translate many expressions to other languages. It seems to me that it's very trained on English. And if you work with, especially like me, like historical data that's not, translated into English, will this help, like you're saying now, in translating, or will it actually divert us and go maybe possibly completely wrong?
I think, I can answer then for sure. Raj and Roman have their own experience, but for me, I think sometimes happen because I'm my main tongue is Italian, but sometimes I speak a bit of French, so it's happened that I have a chat that are multi-language, but depending what is the problem, it's no an issue to answer. But maybe for some concept, there are some concepts that are explained deeper in one language than another, so for sure there is some issue there. But I feel that the translation it's pretty straightforward. And I'm not using it to do translation, but when I speak in one language and another, the answer is pretty much the same.
I may add, because I've been involved a lot in this language discussions also here in Denmark politically. Luckily, I was very happy to be part of the group that's actually stopped a law proposal in the parliament, which was trying to waste some taxpayer money on training a Danish model in a certain way. But ultimately, a lot of these things around, for example, language and multilinguality, for me, from my point of view, on the same also goes, I think, for the whole CO2 debate and this kind of, they are using so much CO2 and all of these GPUs. For me, it looks a little bit like these typical things that we see in what, Clayton Christensen was talking about, disruptive innovation and the underperformance of the new technology initially. And because we also see that models over time, I mean like within a year, have suddenly become multilingual, and they are being trained up to be multilingual or domain specific. And we have seen immense improvements in terms of efficiency. Models that had a performance of us, last summer, and would need certain types of GPUs to even run. Now the same can be achieved with models that can run on a MacBook PC, on a MacBook Pro, for example. So we see very strong efficiency gains. We see that many of these problems like multilinguality are token cost and things like that are being addressed. And so that's more of a question of time, I would say.
Before you answer, Arash, you presented us all sorts of different frameworks for using AI. We had like lots of colors and arrows between boxes. And do we run the risk of no longer understanding the research that we're doing by relying on these large language models?
Yeah, I mean, definitely that's indeed like, the reason why I was also calling it like a black box, because, if there's no way to diagnose, then you have very little room for kind of leverage and do any sort of correction. And that's why, if you even Google up these evaluation frameworks within LLMs is becoming very prominent, and there's like many frameworks coming in and different ways of, how to evaluate. And it was an interesting case, that I showed you the sustainability pipeline, that, how to extract, kind of these company sustainability guidelines and framework. And when we try to map the LLMs findings with the humans, we noticed that, okay, 50% of the cases, or actually 57, almost 60, it was very much overlap. So both human and LLM were basically saying the same thing. But in that 40 case, we invited those individuals into the room and basically showing them that, okay, LLM has said this, and you have said something else. And that was a very interesting debate because even humans were not sure if they are right or wrong. So at the end, I think the finding on that exercise was that, it helped us as humans to make a bit more of a crystal clear frameworks and guidelines to even, do such exercises. So I think that the outcome of that work that we are now writing it for a publication is that it helps us to understand, how we can improve the quality of the framework. Because to some extent, the LLMs were very kind of straightforward. They had instructions, they had guidelines, so they would never miss. Because if you put it in a certain way, they are very kind of relying on that case. And then we also embedded another methodology to kind of put different LLMs to do the same task, and then they convene together and then basically average out the finding. Because when we talk about LLMs, they are trained on a certain data, and that data kind of describe their powers and the kind of proficiency in a certain area. And some LLMs are very good in medical documents, some are in a different one. There's almost now 600 LLMs out there, GPT having only 5 of them. So then the question is that, it's becoming more of like a LLM debate. They get to do the task and then they look at each other's answers and then they average it out. And what I see is that these paths, these 40% gets 30%, gets 20%. So over time, I would say that AI and LLMs becoming much, much better in performing such tasks because they can comprehend much more. They can take more information compared to a human where like they had to open a tab, look at the framework, and then they had to look at a document to do those kind of mechanics.
You worked at different organizations. You've mentioned a few in your presentations. Will the organizations that do not embrace the use of LLM or master them be left behind? And for example, Pietro, we have this discussion with Statistics Canada. Roman, you talked about the Danish government. So Pietro, tell us more about, what are the challenges of these organizations?
I think we started 1 year ago with putting in place a framework with Stat10. And I think the main issue was they were not ready to use a framework that they didn't know about. So obviously, like there was all this. This was the first part of the work was just to help to like understand what was the goal of the project, which methodology involved in the project, and how to ensure the security of the data that they were using. Because obviously, like when you work with with the governmental organization, you had to ensure the security of the data first. So all the building the framework was I think took the majority of the time. But at the same time, what I feel is that I think this type of organization have the power to validate the model, right? Because we talk about how the validity of the model is one of the main problem. And I think these organizations are the one that they can have like the data to validate all this approach. So from one side, there was all the put in place the framework. On the other side, there's the advantage to collaborate with this organization because you have the data, you can evaluate the method that you are trying to use or explore. Yeah, the only problem is that you don't have the freedom to do research, right? In the sense like sometimes there is a bit of the freedom of the artist, right? You are doing something in the research and then you can explore something else, but you don't have this freedom. You are limited to one precise goal. So I think this is the disadvantage about on the other side, you have like a great amount of data that most of the private organizations do not have.
Ash quickly, and then Roman, you'll have the last word on this question.
So would you repeat?
Working with different organizations, would they be left behind if they do not embrace LLMs?
We actually did like a larger scale survey in Finland, and we realized that there is eventually a deviation. So some companies are very much embracing it; they're trying to learn, but then some others are very much restricted, and they are not really kind of giving a lot of opportunity for their employees to also try with. And one of the caveats there was like the people who were having the opportunity to use with these tools, they kind of emphasized the importance for learning because they were also they had a higher kind of sensitivity about their job security. So in a way, if the organization is not very much looking at the facts and the comings of these models, they are omitting the chances for their employees to learn these things, which eventually not learning them will lead to kind of in a very extreme case, job replacement, not necessarily by AI, but somebody who knows how to work with these AI models.
Okay. Roman, the last word.
Final word is mine. Thank you very much, and thanks for moderating so well, Catherine. So I think what, if I may just kind of do the crystal ball thing right now, I think what is happening right now, we're in a transition phase, and these things they're coming, they're new. We are getting every week, there is a new open source model that you can just download and run on your own infrastructure and all kinds of things. But organizations are slow to understand. So what are the mechanics of that? As soon as we are slowly getting out of this phase and things are maturing a little bit, we get more and more dominant technologies there. What I think will happen is basically that, this will, right now, this is driving the price of automation extremely down. A lot of things that organization would like to, be automated and be routines being automated. That was very expensive to build software, to build, systems for that. Now this is getting very cheap. And I don't think that we will see so much these kind of chatbots around. Yeah, they will still persist. But what I see is organizations just building software and automations that are happening behind, the scene. It's not so much the individual employee that's going to the site and use some kind of Microsoft Copilot. Again, I see this a bit as a transition phase, but it will just, be automated processes that will kind of disappear in the background and the organizations that will adopt it will become more efficient, and it will have, the typical kind of selections processes that we know about in this community happening. And then I think for the public sector right now, there is a bit of a problem because they cannot jump on the train as quickly. They have to, there is a lot of compliance issue and a lot of these kind of things. And for small companies, the same. They don't have the capital right now to, just jump into it quicker. But, these things, they will develop, and let's see where this goes. But ultimately, it's just like speeding up automation. This is what I see happening right now. And then to some extent, some augmentation is also happening. Yeah.
Okay. Well, thank you all three for a very, inspiring, overview, from use in research and use in government and in industry. I think we've covered quite a wide range. So, thank you, all of you. So, is Maureen starting at 2:30 or at 1:45? Can't remember. 1:45. So we have a bit of time for Q&A if you want to ask questions. So feel free to. Yes.
You were mentioning, Raj, that the gap between open and closed models are getting mitigated now, right? But do you think that there is a common ground that we can have semi-open model, right? Just hypothetically speaking, because most they have advantage in different contexts.
Well, the difference comes with the licenses. So when we talk about open, it's not like open. So a lot of them are still restricted for using like commercial kind of utilities. But by open, it's like, the ratings are available. So, and that's basically how the models are functioning. So there's like always this rating per vector or the way that they quantify the language. The benefit is that, because the field is very much on the development. And for example, when you look at Meta, they also open source a lot of the models because they don't want to be liable to the consequences of these. So they are still testing the grounds. I mean, if you look at OpenAI, they are in a deep trouble with all of the law cases, and they have to now do a lot of kind of challenges in face. But Meta doesn't have, because the licenses of their tools is so that they are basically, it's out there for everybody to try. But at some point, we will see that many of these kind of open source kind of become closed and go to the commercialization patch, similar to like what's happening with the Mistral, the French initiatives, which is now becoming a closed and in a way, a version of a commercialized model as well.
When talking about open, it's more related to the on-premise, right? Or
open means like it's not. I mean, it's open for
for example, now because I'm looking at healthcare sector, right?
Yeah.
And there's a lot of hospitals starting to adopt this on-premise, and they're favoring Llama over other models.
I mean, in a way, they are free to do and onboard those to retrain and repurpose, while you cannot do the same necessarily with like a commercialized one because they don't offer it like that. So, and then the issue is with the sensitivity of the data. With open source, you can actually have it on your premise. If you have sensitive data, you have that leverage to kind of run it on a very secure environment that you decide. With the commercialized ones, that's not an option. You always need to send it to like some via an endpoint to some cloud or whatever it might be out there. Yeah.
Roman, did you understand the question, or you?
Yeah, sure. I mean, pretty much I would have answered very similarly. Just to give another example, I'm involved in a project with health data here in Denmark, and we look at patient journals, like ultra sensitive data, and we're using the Llama 3 model that's been released not so long ago by Meta, and it is on a server basically is in the basement with disconnected from everything but the power, and it works and works rather well. The question there becomes, of course, how do we make sure that the model is doing exactly what we need? So like, the moment when we aim to do is to have the model summarize these patient journals so that the moment that the GP is receiving a patient, they get the information that they need because they only have maybe 3 minutes between patients. So, and that's the kind of applications, that we can build today, where it becomes very, very important. Like what we do is just this whole idea of how do we make sure that's not inventing a disease that's not there or missing something that it should have been picking up. And these are these kind of evaluation pipelines that have been mentioned before here. But yeah, from a model perspective, you can use open models for that. You can really force them to output this kind of output that you want them to output, and it works quite well, even in such a secure environment.
Fine-tuned on the premises.
We don't even fine-tune it. We actually, a Llama 3 70 billion model that is freely available can do the job without any fine-tuning. So just with instructions and very clear steering of what we wanted to do, because summarization is a rather easy use case for these models. If you give them information, say, please summarize this doctor's notes with focusing on these things, it's highly unlikely it will make a mistake there.
Thank you, Roman. I think we're just going to have to stop because you're competing with the coffee break.
I really don't want to do that. So have a nice coffee break and enjoy the conference.